Good morning or afternoon, whatever it may be for you. So in this video, we are going to talk about what a variable expression is, and we're going to define the different parts of a variable expression. So let's get started. Before we talk about variable expressions, though, whenever we talk about order of operations, you guys are dealing with numerical expressions. So for example, I might have something like 5 times 3 plus 2 squared minus 6 times 1. That is a numerical expression. Let me give you another one, just another example here. What if it was like 6 times 4 plus 10 divided by 2 times 3? There's another numerical expression. And if you remember, back in, well, whenever you probably learned about doing the order of operations, sometimes people said, let's circle the terms. And terms were separated by plus or minus signs. So at the top one, I would go all the way over here. That would be one term. There would be another term. So one way to help us to evaluate numerical expressions is by circling the terms. Okay, and terms are separated by plus or minus signs. So we're going to keep that in mind for a couple minutes here. But again, you've already been talking about numerical expressions. There was no variables in here because we knew all of the numbers already. All right, so let me erase this board. I want you to get out your toolkit if you don't have it already and turn to page 20 so we can start talking about a variable expression. Okay, so what I want you to write down is the definition of a variable. A variable, well, we use letters to represent quantities that are unknown. So in the previous one, there was no letters, it was all numbers, so we could actually just evaluate that problem. So now we're going to start using variables to represent numbers that we don't know. In fact, you've already been using variables. So for example, I just changed that word, that's okay. We used variables when we were using the formula to calculate the area of a triangle or the area of a parallelogram. So area of a parallelogram is A equals base times height. Now technically that's not an expression because of this equal sign here. That makes it an equation. So if we take the A equals part out, right here we've got a variable expression. There is no numbers at all in it. There could be, but there's not. The B stands for whatever the base might be in a problem, and the H stands for the height. And since our problems change and not every parallelogram is the same size, we have to have letters to represent what that variable might be. Okay, so let's turn now to page 24 in your toolkit, and we're going to talk about more different parts of the variable expressions. Okay, so hopefully you are on page 24. I want you to have a highlighter or a colored pencil, something you can mark in your toolkit with, and let's highlight some important information. So a term is an expression that contains a single number. Now this is pretty important here. That single number by itself is called a constant. It could be a single variable, or it could be the product of numbers and variables. Okay, so let me give you some examples of what that means to the side here. So a constant would be like 5. 5's a term, but it's called a constant number because there's no variable with it. Or it could be a variable, so x by itself is a variable, b by itself is a variable, so that those are all terms and they would be part of a variable expression. Or it could be the product, remember product means times, of numbers and variables, so something like 5x. Now, if there's not a dot or a time symbol in between a number and a variable, that means that it's multiplication, so it's the product. Okay? It could be a whole bunch of things. So I could have something like negative 3abc. That would be a product of a bunch of numbers and variables. Okay? And I do want you to notice that in each of these, the number part was out front. Okay? So whenever we have terms that have variables in it, the numbers would be out front. Okay, so back to what's in your toolkit here. We need to know what terms are and talk about them a little bit because we're going to end up combining like terms, and we'll talk about that in the next video most, but right now we need to talk about what like terms are. So this is really important. Like terms are two or more terms, remember terms are separated by plus or minus signs, that have the same variables with the corresponding variables raised to the same power. That is really important. So the variables have to be the same power, and it has to be the same variables, okay? So let's look at these examples down here. Some examples of like terms. So the 2x squared and negative 5x squared, they are like terms because they both have x squareds with them. The 4ab and the 3ab, they are like terms because they both have an a and a b with it. Now I want to point something out to you. Notice the 4ab and the 3ab. If it was 4ab and 3ba, they are still like terms. Usually, just so you know, whenever we have a term with more than one variable, we usually write them in alphabetical order. That way it's easier to tell. So really, we could just rearrange the a and the b because we're multiplying. Order doesn't matter when you multiply. Okay, so some examples of terms that are not like would be 5 and 3x, because the 5 does not have an x with it, so they are not like terms. The 5x and the 7x squared, they do both have an x, but remember, if there is a variable, it has to be the same power, and the 7 has the x to the second power, and the 5, the x does not. And then the a squared b and the ab, again, they both have ab's, but the one, the a is to the second power, and the other one it's not. So those are just some examples of like terms and not like terms. That is going to be really important for you when you're doing algebra, knowing whether something is a like term or not a like term. So now I need to talk a little bit about, so there's the word coefficient in there. We already talked about the constant. Remember, a constant is a number that does not have a variable. So 5 would have been the constant term up there. Okay, so let's talk about what a coefficient is. Okay, so let's talk about coefficients of some of these variable expressions, or some of these terms that I wrote at the bottom here. If we look at 5ab, and I asked you, what is the coefficient of ab? The answer is just 5. So 5 is the coefficient. It tells us how many ab's we have. And so that would be the term. The term is 5ab. The coefficient of that term is 5. Now let's look at the x squared. This one's a little bit tricky. X squared is my variable part of it. Now when somebody says, what's the coefficient? They're like, wait, there's not a number in front of x squared. Here's the deal. If there's not a number, the default is that it's a 1. So the coefficient of any variable term that doesn't have a number in front of it is 1, okay? 1 is the default. All right, look at the 2x squared plus 3x minus 5. That is a variable expression. It actually has 3 terms in it. Here's 1, here's 2, 3 terms. Terms, remember, are separated by plus and minus signs. The coefficient of the x squared term is 2. The coefficient of the x term is 3. And then here's the tricky part here, the negative 5. See how it was minus 5? Think of that as adding a negative or adding the opposite. So that negative 5 is what we call our constant term. There's no variable with it at all. And I would say the constant term is negative 5, not just 5. All right, looking down at the 14 minus b, the constant term would be the 14. And then if somebody says to you, what is the coefficient of b? Here's again where you have to be careful, because there's not a number directly in front of b. So I am going to think of it as adding a negative. Think of adding the opposite. And then since there's not a number there, remember, it's a 1. So the coefficient of the b term would be negative 1. So that's a tricky one. All right, so that's what the coefficients are. That tells you how many of each kind of term that we have. Be careful there's not a number in front. It's a 1 is the default. And if it's a minus and a letter by itself, or if there's a minus and a number, then think of that as a negative. Okay, let's move on to the next thing. Some really quick questions. If I asked you how many terms, look at the green variable expression. There is 1, 2, 3 terms. Remember, they're separated by plus or minus signs, and there wasn't any parentheses, so we didn't have to worry about that. In the dark pink variable expression, there is 1, 2 terms. So 3 terms, 2 terms, and the last one is just 1 term. Okay, the next question, what if it said, what is the coefficients? We just talked about that in the last screen. The coefficient here is a 4. Coefficient of the x is a -2, and this constant term, there's that last question, is 5. In the middle variable expression, the constant term is -6, and the coefficient of the AB term is 4. And then in the last variable expression, we only have a constant term, which is 22. Okay, so really quickly, talking about like terms again, there is a bunch of variable terms across my screen here, and I'm going to put the like terms together. So if I look at the BA here, this also has a BA. Now, it is not in the same order. Typically, I should have written that 17 is 17AB, putting it in alphabetical order, but they do have the same variables, and the variables have the same exponents, so 17BA and 5AB are like terms. Okay, the -45 and the 13, now their variable terms, there's no variable with it, so those are both constant terms. They are like terms. They would be the constant terms. And then the last two, we have this x squared and the 2x. They are not like terms, okay? These guys, not like terms. They both have x's, they both have a 2, but in the -x squared, that little 2 is your exponent, and in the 2x, the exponent there is actually a 1. That's the default. So they are not like terms. They're only like terms if it has the same variable and that variable has the same exponent. Okay, so hopefully this was helpful. Just some vocabulary so that we can start actually combining like terms in the next section.